I'm going to show how to make polygons using shader methods in Affinity Photo's procedural texture filter. So here's my triangle. I can control the number of sides of the polygon with this parameter, and I can control the number of cells there are with this one. I can control the size of it over here, or I can control the rotation with this, or if I hold shift down, I can go to any rotation. And then I can, with the edges, I can control the fading of this, and I've got it set to be controlled, pass through a gradient map over here. So I can use that gradient map, and I can rotate these around like that. So in this video I'm going to show how to do that. So I'm just going to delete this one, and I'm going to turn off the gradient map. I'm going to start over. I'm going to implement a Polygon program from the book of shaders, and I'll put a reference to it in the description for the video. This is the formula I'm going to be working with. It's pretty long. It's got cosine and floor and theta and degrees and length, all this in here. I'm going to be working through this and explaining it step by step as I build up this formula. So if you don't want to listen to the math part of this, skip to the end of the video, or just grab the equation, and you can make use of it if you want to. First thing I'm going to do is to add a live filter, procedural texture, and I'm going to create an equation, assign it to all three channels, and I'm going to call it variable v equals vector 2 of x comma y. Then I'm just going to show vector v. Okay, so it turned the whole thing yellow, but if I zoom in on this corner here, I can see that there's a little reddish line and greenish line and sort of a tan line there. So if I look at what's going on with that, I have x going from 0 to 1 this way, y goes from 0 to 1 this way. Now at this point it must interpret that as 0.5. So it really is treating this as sort of a floating point number, with this corner being this origin and then increasing by 1 unit each time as you move across here. The other thing to notice is that y is increasing as you go down. With regular Cartesian coordinates, y increases as you go up. I'm going to divide by the width of the document, w, and that creates this image, which goes from black up here in the corner to yellow over here in this corner. If we look at this, x is 0 over here, and then it goes up to 1, a value of 1 as you reach this edge of the image, and then y starts with a 0 and increases to 1 at that edge of the image. Notice that it's taking the x component and assigning it to the red channel, and the y component and assigning it to the green channel when you present it like this. So I could also, if I turn off the green channel, now the x is still going to the red, but the y is being assigned to the blue channel. I could also have it just green and blue, where the x is the green channel and the y is the blue channel, like that. But I'll just leave these all on for now. I'm going to add a factor A. I'm going to call it cells. I'm going to just set that to 1 for now. And I'm going to multiply this vector by A. Now when I increase this, I can see that this yellow region is increasing. What's happening here? So I'm going from 0 to 1. That's where I have that original shape, the original image. Once I pass 1 in the x and y dimension, it goes to solid yellow. Okay, so what I'd like to create is a repeating pattern, and so in order to do that, I'm going to take and I'm going to I'm actually going to change this one to v0, and I'm going to create a new variable, and I'm just going to call that v like I had before, but now I'm going to take the fraction of v0 like that, and I'm going to present v as the image. Now with this set to 2, I've got duplicates of this. I can increase this to 3, 4, 5, whatever I want. I'm going to leave it at 1 for now. So now I have this sort of repeating pattern. So the fraction takes the, just removes the whole number part of the number. So it goes like, instead of going from 0, 1, 2, it'll go from 0 to 1, 0 to 1, 0 to 1, 0 to 1. It just keeps repeating that pattern in both dimensions. Now I'm going to work with a polygon, and so I have to have, in order to create the polygon shape, I need to create a angle. And to get an angle, I'm going to call it theta. I have to do a variable, and I'm going to call it theta. And it's going to be equal to, I'm going to use the arctangent 2 of v dot y and v dot x. So I'm going to take my vector, my coordinate vector here. I'm going to look at the y and the x components of that. I'm going to use that to get my angle theta, and then I'm going to just present theta to all 3 channels like that. And it looks like it went all white at first, but if you look up here in the corner, you see that there's a little bit of shadow up there. Also, I can increase the number of cells like this, and if I look at those, I see that this is 1 degree of arc right here, showing up in that. Remember, my y dimension increases this way, and it's minus y that way. And then my theta, angle theta, is rotating this way. Now if I look at the arctangent function, it returns a value from minus 180 to plus 180. But because my y-axis is reversed, pointing downward, my angle is going to go in this direction, is a positive theta, and then this, the opposite way, will be the negative theta. Now I'm going to add another variable for the number of sides. That will be n, and I'm going to set this up to 4 sides. 4 is going to make the math a little easier. I'm going to use this n to create another variable. I'm going to call that dg, 4 degrees, and I'm going to make that 360 divided by n. So in this case, since n is 4, that will be 90 degrees. Okay, and then I'm going to divide my theta by the number of degrees in this shape, which for a 4-sided polygon is 90 degrees. For a 3-sided polygon, if this is 3, that'd be 120 degrees in it. And even though a triangle is 60 degrees, we need to look at the the angle of the arc of the side that's going to be cut out by that. So anyway, that'll be 120, and then as this increases, this will get smaller and smaller. So in this case, we're going from 0 to 1 as the angle goes from 0 to 90 degrees. Okay, so I've divided by the number of degrees in this, I've divided by 90, so this is going from 0 to 1 in that distance. The next thing I want to do is move my origin. So my origin is up here in the corner, so I know this wraps around, it'll go from 0 up to 1 here, and then from 1 to 2, and then it'll go backwards, -1, -2. So I want to move this origin to the middle so I can see the other quadrants of my image. In order to do that, I just go over here where I took the fraction. I'm going to subtract 0.5 from that. One of the things that I see is that this is minus 0.5, and it subtracts from both the x component and the y component of the vector. And so if my vector is with a position on here that used to be 0.5, if I subtract 0.5 from that, it's now 0. So I've moved my origin from up here to down here in the middle. Also, I notice that this is going from 0 to 1 over here, which is 90 degrees, and then as I go up to 180 degrees, it's the value of the value of this is going to be 1 to 2. Now over here, I'm going from 0 to -1 and -1 to -2, and so that's corresponds to -90, -180. Next thing I'm going to do is I'm going to take the floor of this. Floor rounds down. And so it cuts off this gray area. It makes everything black and white because it's going to go in steps, whole number of steps. But floor always rounds down, so that means that the negative part of this part's going to be 0, but up here in this quadrant I'm going to have -1 and -2, and then this will be +1. If I divide by 4 and add 1/2, you can convert those to grayscales. So this would be my 0, this is 1, this is -1, that's -2. Now again, floor rounds down, so if I have a -0.1, it's going to round that down to -1. It seems like it hasn't changed, but it actually has. It now goes, this quadrant is now 0, this quadrant is 90, this is -90, this is -180 degrees because I'm multiplying by 90. Now I'm going to turn off the floor function for a second. I'm just going to delete that and take off this. Now what I want to do is rotate this backwards a little bit so that I need to rotate this backwards so that my 0 is up here on the 45-degree line. In order to do that, I'm going to add 0.5. This goes from 0 to 1, then 1 to 2, 2 to 2.5. Or if I were to multiply this by the number of degrees, I'd go from 0 to 90, 90 to 180, 180 to 225. And this part would go from 0 to -90, 0 to -135. Now we're going to put the floor back on. So it's going to round off this part, and these will be negative. And I'm going to multiply by my degrees again, times 90. Okay, and that looks like it didn't do anything, but it actually has. So this section is all 0. This section is now -90 because I'm multiplying by the degrees. This one is -180. This section is +90, and this sector over here is +180. So keep that in mind as we get on to the next part. So now I'm going to subtract theta from this, and this was the part where I got really lost. Oops, minus theta. I'm going to subtract the angle from this, and it gives me that, a pinwheel. This gets really complicated, but here we go. I'm going to look at this. This quadrant, if you remember, was 0. The floor section is times dg. That's all going to be 0. This section over here is going to be -90. This one is -180. And then over this way we get +90 and +180. Now we're going to be subtracting off theta. Theta, remember, goes from 0 up to 180 in this direction, and from 0 to -180 in that direction because of the arctangent 2 function up here. And so when we're now going to be subtracting these, so I'm going to look at what happens at these boundaries. So I'm going to subtract, I'm going to take this, which is the blue number, so that's 0, minus theta, which is 0, so this one will be 0. And then I'm going to take, this is still 0 because it's a floor function, right? So this is still 0 up here, -45, 0 minus a negative 45 goes to plus, and so that's equal to plus 45. So this region from here is going to 0 to plus 45. Now it transitions over to minus 90. So I got minus 90. And I'm subtracting a negative 45, which is plus 45. And so that's equal to minus 45. This is down here at this place, it's still 0 before I cross over to this transition. So it's 0 right here. And then minus 45. So that's minus 45. So what we're going to end up with is in this region, it's going to go from minus 45 to plus 45. Here it's going from minus 45 to plus 45. Here we're going from minus 45 to plus 45, and here we're going from minus 45 to plus 45. So repeating this range from minus 45 degrees to plus 45 degrees. By the way, this has this cool pinwheel effect. You can, if you increase this, you can make tons of those pinwheels, and then as you increase this, you can create a pretty interesting pattern with all these pinwheel patterns. But that's not what I'm after here, so I'm going to go on to the next step. I'm going to take the cosine of the floor, 0.5 plus theta, divided by the number of degrees, times the number of degrees, minus theta. So I'm almost there. You just have to take the cosine of this. So I'm going to do that. Cosine of all of this. And I'm going to go back down to 1. Okay, so that's cosine of this, but remember it was set up so that this is minus 45 to 45 degrees, minus 45 to 45, minus 45 to 45. So the cosine is just looking at those inputs, a range that's sweeping from minus 45 to 45. And we know from math that if we take r times cosine of theta, it creates a projection along an axis. So like along the x, usually along the x-axis, it'll create a projection of that. So if we treat these as just numbers going from minus 45 to 45, that's all the cosine of theta knows. It's going to create a line that's sort of perpendicular to the origin along that range of degrees, which is exactly what we want. So, but I've got to multiply by the radius. To get the radius, I multiply I use the length function to give me the radius of my vector, or of my xy space. So I multiply by length, and when I do, voila, it's turned into squares. It doesn't look like a perfect square yet, but I can see sort of the straight edges on this. Also, if I change n to decrease this, I can see I have my 3 edges there, or if I increase it, I get 4, 5, 6, 7, etc. So it's working. So now all I have to do is put a step function on this to add some contrast to it. So I'm going to put a step, and I'm going to use the smooth step. And actually I'm going to add 2 edges first. I'm going to add, these will go from 0 to 1. I call one of them edge 1 and one of them edge 2. I'm going to set edge 1 down to 0. Oh, this I'm going to call the sides. That's the sides of my polygon. This I'll just call edge 1, and this one I'll call edge 2, like that. Right, oh, and then I have to add my function, so that's going to be smoothstep of E1, comma, E2, comma, and then a parentheses around this whole thing, like that. And now, when I bring this up, it increases the blackness, but when I bring this down, it decreases the white, and when I get to this point, okay, now I've got a square. Also, if I change this to 3 sides, I've got a triangle, I've got a pentagon, hexagon. Okay, I can just keep going and increasing the number of sides. So it works. However, my triangle is pointing off to the side, so disappointment. But if I go up to here where I calculated the tangent, I can try adding something to that. I'm going to try adding 90 degrees to that and see what happens. Okay, it's pointing down, okay, but better. So I went the wrong way. Let's try 270 degrees. Okay, it's pointing up, so that's good. But now that I see that, why not add a rotation control? I'll call it phi, since I already used theta, and this will be, I'll just call it rotation, and I'll put my phi up here, and so that I can, there, now it's right. And then if I go up to 5, it's also correct. And as I add more cells, that looks good. And I'm going to make these a little bigger. And now, look at that. They all rotate at once. If I hold the shift down, I can get these to all rotate. Okay? I love it. I don't know about you, but I'm excited. All right. Now, the next thing is, this is good. I like it. I put these back like this. Now I'm wondering if I can make a, instead of just a solid shape, I'd like to make like the outline of the shape. In order to do that, I've got to get the inner part to go down below 0. So right now it's sort of bottoming out at 0 here. I need to get this inner part to go below 0. I'm going to go back to a square again, and I'll just go back to my big square. So the first thing I'm going to do is I'm going to multiply this cosine part by 2, and then I want to be inside of the smooth step, so I want to subtract off 0.5, and that pushes that below 0. Okay, so now it's all dark in here, and I want it to come back up again. So what I'm going to do that, I'm going to take the absolute value of this, absolute value of that whole thing. There. So now it's coming back up in the middle. And now, when I adjust the edges, I should be able to get this to be a certain shape, like that. Okay? And so I can mess around with these to get those edges just right, to get those shapes. However, there's another way to do that. I'm going to create a B, which is going to be the, I'll just call it size. I'll set it down around here. And instead of subtracting off 0.5, I'm going to subtract out B. Okay, now the edges control the thickness of the line, and B controls the size of the shape. And these could be, see, these could be set to have, smooth edges, and B will still control the size of that. I can increase the number of them. I can increase the number of sides, and I can control the rotation of these. So last thing, I'm going to turn on a gradient map, and now I can do this. So if I apply a gradient to this, I can change the size like that. I can change the rotation like that. I can change the number of size or the number of these and rotate them. You can find more information on this in the book of shaders. Let me know if you have any comments or questions, and thanks for watching.